Ever wonder why matter is solid? Why steel, rock, and diamond have real strength, even though an atom is almost entirely empty space? Only a tiny fraction of an atom's volume, about 1/10 trillionth, is occupied by the nucleus. To illustrate this, imagine the ball of a ballpoint pen as the nucleus of an atom. Then we zoom outward, all the way to the atom's outer region. And here's the scale: the sphere that represents that region is large enough to hold an entire football field. So are the atom illustrations in textbooks drawn to scale? No, it simply is not possible. So where does the stiffness come from? According to the standard explanation, electrons exist as standing wave probability clouds, superpositions, that create stable regions around the nucleus. When atoms get close, their electron clouds overlap in ways that resist further compression. But this explanation quietly leaves something unspoken: how a region that is almost entirely vacuum can behave as if it has real mechanical stiffness. The math describes the behavior, but the mechanism is never addressed. If the vacuum behaves like a medium with stiffness, then displacement stores energy. Resistance to accelerating that displaced region becomes inertia. Gradients in stored energy become gravity. The familiar properties of matter emerge from the mechanical behavior of the substrate itself. And here's the part most people never think about. If matter is built from displaced substrate, then the stiffness of the vacuum cannot be lower than the stiffness of the hardest materials we know. You cannot build a structure stiffer than the medium that carries its internal stresses. Diamond is one of the stiffest substances in nature, and even diamond is made entirely of displaced vacuum. So the vacuum must be at least diamond-class stiff. Not as an assumption, but as a mechanical consequence of the fact that matter exists at all. The rigidity of the world around us is telling us something about the rigidity of the medium beneath it. Once you accept that the vacuum has real mechanical properties, stiffness, impedance, and loadable energy density, the pieces begin to fall into place. Mass becomes the energy of nucleus-driven substrate displacement. Inertia becomes the resistance to accelerating that displacement. Gravity becomes the gradient in stored energy between interacting bodies. This channel follows that idea from hypothesis to modeling to experiments. Nothing here is final. This is a work in progress, built in public, step by step. If the model is right, the math will show it. If the math is right, the experiments will show it. And if the experiments work, we may gain a new mechanical understanding of gravity. This is the hypothesis. Welcome to gravity as I see it.